So today on the bench, I thought we would take a look at this P104. The battery gauge is not showing any indication on the battery. This battery, I put a 408 date on it. So this battery is right at 11 years old at the time of this video. I thought we'd take a look inside. Being a double stack battery pack, I just thought we'd look at it and see what the differences are, how similar the board is compared to the compact battery pack that we took apart on the last video. And just look at the differences, even though being an older pack, and just see what might be similar. We'll take loose the connector that goes to the battery gauge or indicator. That's just in there with some foam on the edges, making it tight, but it does slide out. We bring our meter in. I have marked a plus on this side. Help me keep up with it. Plus to minus here. On the battery itself, I'm getting out 13.57 volts. So again, this will be one of them batteries, like we mentioned on the previous video, that somebody might feel led to put 20 volts across here and try to jump or pulse this battery up to taking a charge, because we saw that the charger rejected it and showed it was a defective pack. But we noticed, being that low, that it's very possible it could be some bad cells. Not just that all the cells are low, even though that wouldn't be a good thing either. But we got a 3.4 on these bunch, and I've kind of taken this off a little bit so we can see that foam is just a disaster. It's a bad idea. But we see on the double capacity pack that we have 2 rows in series. So these N2, for example, are not only in parallel, but they're in series with this bunch as well. This one goes through, back in parallel. It's in series with this one that's in parallel coming back. So our 1, 2, 3, 4, 5 at nominal 4 volts gives us 20 volts and double the actual amp hour rating or amp hour of the battery pack itself. So knowing that, one thing about these double capacity or higher capacity packs that's in parallel is either just one cell. I put an X here because I've already put a meter across that one, but it could be either one of these go bad, and it can make the other one go bad by pulling it too low. But as we go across, we had our 3.5 there. On this other set, 3.5. We got 3.6. Not looking like a bad bunch of batteries here. 3.5. All fairly consistent. This last set, which I did already put a meter on a minute ago, I just didn't have the camera going, 0.5 volts. So this is another one of those instances, not to harp on it, but you would not want to put 20 volts across this battery and try to bump it up. All you'll be doing is overvolting these other cells that's already at 3.5, 3.6 volts. And this one's only 0.5, but yet again it's letting it through. The resistance has dropped and allowing a lot of the voltage to go through. If we take a look here, from the negative all the way to this battery, we get 14.14 volts, and coming across these we're getting 13.57. So we're dropping roughly half a volt across these batteries due to resistance. That's why here we're getting our 13.57. So just think about that for a minute. This is coming all the way back to the battery terminal, or at least it may be going through these transistors. I hadn't traced it out, but it's probably going through the transistors and coming back through, as long as it's not shutting down, because right now they're fully putting out to the terminals. So we actually having more voltage without including these in the series. So putting voltage across that would not be a good thing. So what I'm going to do now is take this set, and yeah, I did choose this pack because I looked at it earlier, and this will be easier to show because it is an N cell pack. If it would have been, it was the N cells in this pack. If it would have been these other cells, it would have been a little more difficult and more time consuming on the video to have to show getting to that and peeling all this back. But being right here, it's not going to be a bad job to go. Spot weld is not bad either. Those come off real nice. I'm just going to roll this back out of the way. Just that easy. We got that off. Now here we got a little catch, just wanting to keep the cell in. I thought I had marked the plus on this side. I don't think I did. Just to remind me which way the battery goes back. It's pretty obvious because it's going to be the opposite of the one in front of it. The ones in front of it. So there's our battery pack with the cells out. And just to verify, 0.4, and it's actually is showing that negative, about negative 0.4. So the battery has went down way past the point of return. So we look at the cells that came out. That is a Sanyo UR18650SA. And it's actually not that great of a cell, which it's 11 years old, but even 11 years ago, it's only about 12 milliamp hours, so not the greatest cell. Being in a double pack, it did give it that right at 2.4 amp hours. So what I have is some Ryobi cells that are 13 milliamp hours. And you do really want to go as close to the same cells once again as you can. If this battery pack wasn't 11 years old, I would absolutely say put the exact cells in it. But having this much age on it, they're all going to be a little bit different. Going from this direction here. And one thing I didn't mention, typically when I have spare cells and I'm going to use them, I will just take a little bit of emery cloth and rough up the surfaces just so they're shiny. And I put a little bit of flux, rosin flux, or sometimes the no clean keister flux, but the rosin flux works good on this as well. And I just go ahead and just pre-tint it, just get a little pool. You don't want to run too far off the positive, just put a little puddle there. And I didn't do it on my last video, but I almost always do. I just had failed to do it before I started on the video, so that was my bad. It took a little bit longer to complete because of that. But in my previous videos, I've talked about that and covered it in the history of some other pack repairs. So just double check that we're going minus, plus, minus, plus, minus. And these are going to be in parallel. I think I'm going to have to take that foam out of the way. I am going to put a little bit of flux on here. Help transfer the heat and keep the surface clean, especially with the foam and glue residue. I couldn't get it all off. So this is real similar as before. On any previous repair. I do have a 200-watt soldering iron, and sometimes it's better for the larger connections. But this soldering iron with the big tip is so good, it doesn't take that much longer. So I don't hardly even get it out any longer. And typically after it's made a good puddle and it's holding, I will take a damp cloth, as mentioned in a previous video, and just cool the outer surface of that battery, just so it doesn't continue to heat. Just stuck in the rosin flux is all. Put some flux on this side. And I've always had good luck with that. Usually does just fine. On the plus side, I'm just a little more careful not to get a lot of heat around the protective ring that seals around the edge. And what I mean by that, on a cutaway of this one, we're just taking the actual ring off. If you can see the way that they go together, the whole negative housing of the battery just crimps around where the positive disc is, and it's just got an insulator. This one, the color of it, it's actually a bad example. You can hardly see it on camera probably, but it's a gray, almost like an O-ring right there. And if this battery was fully charged, which this one went to 0 volts on me, just like these pretty much from the last battery repair. But if you were to go across right here on a fresh battery or a charged good cell, it'd be a major arc, probably lose the tip of the screwdriver, because the negative and positive is just that close together. So be careful. There's always a few things, and of course you're always doing it at your own risk. You got to be careful. But if you're careful, you won't have any issues. Just make sure you solder directly to the tip, and just don't get outside at all of the outer ring. Now there's one step that I did miss on purpose. I just wanted to show. I think it'd be better demonstrated to do it and then talk about it later. But I've talked about it in other videos about balancing cells and being careful. And we realized here, right, that we had 3.5 to 3.6 volts on all these cells. But what did I just put in there? It's a parallel set of batteries. And no matter what you put those in at, they're going to equalize. And it wouldn't have been a good thing at all to put a weak battery and a fully charged battery, because as soon as you put them together, the current would have flowed tremendously from one to the other. But what I had already done is charge these cells to 4 volts, and I think it was right at 4.1 volts when I charged them. But it's been a couple weeks ago. So let me see in parallel installed 4.05. It looks good because we got over 18 volts here, and more than likely this pack would charge up just fine. But I don't want to do that yet, because one step, and typically I do it before I put the cells back in. I'll go across each individual set and I'll make sure that each set of batteries is charged up to the same voltage level, because they need to be better balanced before they go fully charged. Because right now these cells are almost fully charged and these are not. These are somewhere in the middle at 3.5, 3.6 volts. So to fix that, I'm going to bring in a power supply. All I'm going to do is set this power supply up and go across the cells. And it's going to take some time, so I won't really show much of it on video. I'll just talk about what I'm doing. So back now with the power supply, I got it angled up just a little so you can see. 3.4 volts. I'm going to go right at 4 volts, real similar to the newly installed cells. They are not new, they're used similar to these. So as close a match as I could get. I got the newer or replacement cells in. Now I have to get these other banks up to 4.0 volts. I could have also just charged these to 3.5 or 6 volts, and I think it would have been fine. And I could have stuck it in the charger and let it do its job, but I've already put those in a charger, individual 18650 charger, and it had charged them up. So now we're going to observe polarity, and we're just going to hook our 4.0 volts up with a current limit set of about 1 amp. So if you can see that, I got 1 amp and I got CC, so I'm current control, and it's showing 3.6 just like we measured. And all I'm going to do now is go through, and we're going to see this number drop. Once this number drops closer to 0, and this is going to come up closer to 4 volts where I have it set. So it's okay to do this in a controlled way when you know what you're charging. Lithium cells are fine to do a constant current charge. You just want to monitor the current. You don't want to put just an open source of voltage like another battery pack or unlimited source straight across the cells. But in this case I could go up a little, but I'm just going to keep it at 1 amp. Let these cells equalize to 4.0, and I'm just going to index on down. So I'll be back as this number starts dropping off. It's dropping a little bit already. We'll be back in just a few minutes. So back now, just monitoring the battery pack. We're down to about 0.59 amps. So the voltage has climbed up to 4.0. So this part of the battery pack, these cells are getting pretty close. So once that voltage comes on up a little above 4 and the current starts dropping down closer to 0, we'll move on down at 0.27 amps now. Back now we are at 4 volts and the current is almost to 0. So I'm just going to continue on doing these same cells, and when I come back we'll check in with the meter and verify that they're pretty balanced. Okay, back now with all the cells charged up to 4 volts. We'll do a quick check, verify and show you. 4.05, 4.02, 4.03, gotta go to this one, 4.02, 4.03. So we're very well balanced. Our total voltage is 20.15. Out in the garage at the moment, just going to load the battery up. Going to put a load on the battery and let it pull down since it's fully charged manually, and we'll give it a couple hours and we'll come back. and we'll see how the voltage is. I got the fan on high. We'll make sure they pull down pretty equal, and we'll also charge the battery pack back up and see if it charges up, equalizes okay as well. Back now with the pack after a couple hours running and the fan loaded, we see that it has been pulled down. The total voltage across all cells is 18.87. So we go across our individual parallel group of cells. We have 3.81, 3.72, 3.75, 3.72, and 3.85. So these cells are a little bit stronger than the older cells, but we pull down pretty evenly. So to be a 11-year-old pack, I'm happy with that to get this back up and running. So I'm going to charge it up now, and we'll see how it equalizes and charges, and make sure the voltage don't overvolt on these newer cells. So we'll put it in the charge and see how it goes. Since I'm in the garage, I'm just going to pop it in this charger. And we're charging. We'll be back shortly. A few minutes later, our battery pack is fully charged. Now that our battery pack is charged, we'll check the voltage of the cells. We're right at 20 volts. .04, 3.96, 3.98, 3.96. Get on there. And 4.01. So to be an 11-year-old pack, I'm very pleased with how well those cells are balanced. I think I'm just going to go put the battery pack back together. One final check. You can see that. There's our 19.95 volts and charged successfully. To be 11 years old, in pretty good shape. So once again, just a good way to kind of recondition a pack without spending a whole lot of money on all new cells, and of course tremendously better than, as we mentioned in the previous Ryobi repair, than somebody just putting voltage across. We're just not having any idea what you're putting the voltage across, you know, what the shape of your batteries are. Just keep that in mind. Tried to make the video as short as possible. If you like the repair of this P104, please like, share, and subscribe. Thanks for watching.